It's an air resistance, but on this one graph, this one free body diagram, you're going to have two forces.
What could get its friction to like FR?
No, the only thing you're going to put on this test is these four letters.
Okay.
Do not put anything else. You will miss it. If you put this as anything other than the force of friction, you will miss it.
No.
It's the only time friction will not have a surface. So, friction force is mu F sub n. If there's no F sub n, there's no friction force. You cannot have a normal force without a surface. This is the only case we're going to have a friction force that has no surface. All the rest of them, there will be a surface.
Mr. Bailey, how does that work without a surface? Like, there's no...
It's actually called a drag force, so it's not really friction.
Okay.
I'm stupid.
Having fun hours.
Wait, I'm gonna zoom in on that.
How many more problems do we have?
80.
4.
Mocking.
4.
It is mocking. It's like...
So now it's 5 problems. So that means how many more?
5.
What?
There's 5. There's 10 of them.
10.5.
Oh.
50. That's considered one big question.
Somebody needs to go back to a wrist with it.
50 multiple choice.
There's a 10-point
Just
problem.
like in nerdism, you can use big words when you're right.
I cannot.
This
But
one.
you can't. There's 5 10-point problems. 6.
Oh, look at that stick figure.
There's 2
Oh, hey. That's beautiful. Oh, what is...
How come you don't draw clothes
That's a
on?
weird way to try to open
I wish
the
I
door.
was that tall.
Alright, anyway. This guy is pushing a block against the wall. It doesn't slide down the wall.
That's so perfect.
F net equals 0.
What's the free body diagram for that block that's against the wall?
Wait.
What do you do that?
Well,
It's not moving, so there's no work.
gravity.
Normal.
Which way's the normal force?
Perpendicular
More
to
the
the
person.
wall. Towards the
To
person.
Towards the person.
Perpendicular which way?
Left.
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 Dang it.
Who said it's up? Why does it like touch on the guy's arm?
I did it.
Kevin, you're good. That's not
Any more forces?
Friction.
Friction, what's the direction of friction?
Oh, that's up.
No?
It's going.
It's going upward.
Parallel.
Parallel to the surface, so it has to be up. And then, the only other thing we got is we're going to pretend like he's pulling and make this a tension. Even though he's pushing. You never do a free body diagram where you got an arrow going into the thing, right? Arrows always go away. This is no good. All the arrows go away from the object.
Huh?
You never have a free body diagram where the arrows go
I
through.
drew my nasty one, but I get
Alright.
the point.
So, there's a problem like that. You're solving for something in that problem. I don't know what.
Dude, that's so perfect. Oh my god.
Have a problem with
Oh my god.
arrows going upward.
That's so perfect.
Sure.
It's just like the old
You got a problem here with them arrows going off. We've had several. Well, no, we're never going to put a pushing force or anything. We're just going to assume that they're all going away. So we're actually going to assume he's over here pulling on a rope and just pulling that.
But in reality,
In reality, he's pushing. But we're
Wow.
going to assume he's over there pulling.
Dang.
Right?
why? Mr. Bailey,
Put a stick figure to a wall.
It looks like a silver.
Fuck out.
he's cool.
Are they all equal? How would you tell?
They're all
Not
equal.
going anywhere.
The F net is 0.
Has
So they all have
Is that a wall
up
up there?
there.
Yeah.
Why didn't you draw those little lines?
What happens if it's
That's on the
sliding
ceiling.
down the wall?
And floor.
And
That's
then
for shade and friction.
Friction is less than...
his force. Or whatever you put.
Alright,
Like a
there's
wall?
a couple other problems. One of them is an elevator problem, except it's not really an elevator problem.
Everything.
Or like an escalator.
It's a rocket problem.
Oh.
Oh my god. Wow.
Whoa.
Greatest rocket ever.
So this
That's
is somebody sitting in here driving this rocket.
Maybe at the top.
Wow.
With the steering wheel.
He's driving the wrong way.
Ooh, can you put a
It's
hat on?
okay. Whatever.
As
long as it looks good.
Thanks, Mr. Bennett. Harry Potter.
Oh, he has a hat. He has a what?
Alright, so,
It's Harry Potter.
what are the forces on this rocket?
Is it just
Gravity.
sitting there?
So, no, it's got the engines on it.
Gravity.
Gravity's down.
Is it in the air?
And
Is it
now we're skipping here with this.
Normal.
No.
This thing is not normal. It's called the thrust. And that's the thrust of the engine. But this is F sub T. So the up, if it's accelerating up, it's just like a tension problem, right? It's just like an elevator problem, except it's not an elevator, it's a rocket. But you work it exactly like an elevator problem.
Because F2 represents the force going up.
Right, so Ft is upward force, and gravity is down. Okay, and then there's another problem I'm not going to tell you about, but it's not a real hard.
Why pose that much?
I don't know, just
Can you
kind
write me a story on my
Can
epic
I have the papers after you?
Oh.